All right, I guess we're live. We'll wait for any more viewers who want to come in. I'm showing 0 viewers.
Okay.
What's that?
For a second, it wasn't loading.
Right. Is it showing as being started?
Yes.
Are you? Okay.
Well, maybe check Charles' sound. It's easier for you than me.
I think my sound is sound looks good. If anyone wants to try with headphones, we can do that.
For me, it will turn the karaoke show.
Mm-hmm.
Too much work.
Yeah. So yeah. I'll see if we get any other, if Alric and Joe.
Yeah, I can hear.
Okay, awesome. Let's see, where is...
Anything big?
I wish I'd known we've got the, what's it, for Kano's on the way.
Oh, we'll have plenty to share.
Yeah, that's true. Wait, so you said there were 7 people?
Now it's down to 2.
Now it's down to 2. Well, that's a quick drop. That's a precipitous drop. All right. Okay, so I will go ahead and try and start my screen share. And maybe see if you see my screen, or
Yes. It's teeny tiny though. Can you blow it up?
it's what?
It's tiny.
It's tiny. How about now?
I could use a lot more.
A lot more? Still tiny?
Yeah.
Hmm. Let me just reduce. There, how's that?
Not great. You also have like a Google watermark on it, so you might not want to do full screen.
Might not want to do full screen?
Yeah, it's like the Google watermark is directly over.
Oh yeah, that's weird. Well, I'm not doing full screen. Maybe I should, I don't know what the difference between, what is the difference between presenting and screen sharing?
Presenting also shows your camera.
Oh, okay. Tell you what, let me just, yeah, it's not set to full screen there. There's no watermark now, is there?
Yeah, it is.
There is?
Yeah.
That's so weird.
The size is up there without watermarks.
That is really annoying. Okay. Any idea how to get rid of the watermark?
Maybe instead of
Cash.
What's that?
Cash money.
I guess so.
instead of maybe casting the app, cast like the whole desktop.
Yeah, I could try that. Let me turn my notifications off. And then maybe just go into full screen mode or something like that.
It's casting the window.
Oh,
Yeah.
oh no, it's there.
Is that? Still pretty small, huh? And still got the watermark. Oh, man. Wow.
Yeah, you can't get rid of the watermark, so you have to work around it.
Okay. Well,
Like,
that's new and annoying.
make your window not as tall.
Okay, so I'm going to stop screen sharing for a second, and then,
Bring up your desktop.
yep. Open up, maybe what I can do is, let's see, what if I share the desktop, but then just move the screen over so it's not by the watermark? Let's give that a try. So, blah, 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 blah. Okay, so I'm going to share the entire screen. And then just try and move this down a little bit. And how's that? But the font's tiny, right?
Yeah.
Okay. I really bump it up a lot.
Hey, yeah, that'll just move the window down a little bit. That's good. Right there.
Okay. Oh, that felt unnecessary. So thank you, everybody, for sitting through that. Can someone, like Will or Jeffrey, can you monitor, like, since I can't, with this setup, I can't really monitor the chat window, and if there's any questions or anyone wants to stop me or whatever and ask a question.
Well, can you do that so I can leave this on full screen?
Yeah, I can.
Okay, awesome. So today's subject is going to be monoids. I kind of feel even weird talking about this because I'm certainly not an expert in functional programming or category theory or anything like that, but I've been poking around. You come across it in when you're reading about hardcore languages like Haskell, and then I recently listened to a podcast where they were explaining monoids. I think it was called LambdaCast, and they just did a great explanation, and it just dawned on me how obvious these things were, how we use them every day in our day-to-day programming, but we don't have a name for it, and so we don't often realize that we're using monoids, and so we can't take kind of the benefits from them. So my presentation is very ad hoc, but we'll give it a start, and we'll look at something like let's look. Let's look at something which you might do on occasion, and let's look at like an example of when you might want to like sum up or take a bunch of things in an array here. So we've got two arrays like snack and dinner, and so our snack has two items in it, milk and cookies, and our dinner has pizza and salad in it. And what we want to do is we want to put those arrays, everything in those arrays together, and get a new array that's got all of the items that the old array had. Right? This looks pretty familiar. And what you do is you start with this empty array here, and we're going to reduce it. And we're going to continually build up a new array by concatenating the items of each array onto the other array. And so we get this shopping list, which is an amalgam of, or a aggregation of the other two lists. And so if we do this with array concatenation, you can see that, that when we reduce that, we have a new array that's got all of them in there. So that's a little bit of a contrived example, but let's move on to another. And my only point in demonstrating this is so that you can see that this is something that you do. You probably have written code like this a lot. Is that fair to say?
Yes.
Yes. Okay. So let's look at another thing that we often do, and this is a similar operation, and it except instead of concatenating arrays, what we're doing is we're calculating the total cost. So here I have an order, like your typical lunch. You're eating maybe healthy, so you've got a chicken sandwich and a Caesar salad and some iced tea and your tax. And so the total for your order is we're gonna start with 0, and we're going to keep a running total, and we're going to keep our running total, and for each item in there, we're going to do our cost for that item, and we're going to sum it up. And so the total is going to be this reduction over the prices for each one of the items. And this is something, like I said, is a little bit less contrived because we do that quite a bit. So here you can see the total there is $20.20. And so that's definitely something that we do. And then let's see. There's some other examples where we do here. Like I believe there's like string concatenation. I actually don't have this example preloaded, but it's not hard to say. Like let's say let's come up with 2 strings. And we're going to say, I don't know, hello world. Oops. And let's say we want to concatenate these strings. And so we're going to see something very similar. We're going to reduce these. We're going to start with the empty string. And we're going to pass it a function, which is, and then we're going to return like that. And you can see there's when we reduce those strings, we sum that up. So hopefully we're detecting a pattern here. And it comes as no surprise that the pattern that we're seeing is that we're working with monoids. And so what exactly is this monoid? Well, a monoid works on things that can be mashed together. That's an abstract concept, mashing things together. But it turns out that what we do in programming a lot is mash things together. We mash strings together, we mash arrays together, we mash integers together, we mash objects together. Turns out mashing things together is a really, really, really common operation. And what we're doing is doing a one-off. We're treating each one of these operations as a snowflake, when in fact, there is this concept of a thing that can be mashed together with an operation, and that is what a monoid is. So a monoid is an operation that matches two things together, like strings, arrays, integers. So string concat, array concat, integer addition. And then there's a second thing that makes a monoid, and that's it has this concept of an empty value. And that means that if you apply the operation to any value and the empty value, what you get is that original value. So empty, so operation, empty, and value is just the value. So for strings, string concatenation, what's the empty value? It's the empty string, right? Because hello plus empty string is hello. Empty string plus hello is hello. Can anyone guess what the empty value for addition is? Yep, it's 0. Right, so it's 0 because 5 plus 0 is 5. Oops. And 0 plus 5 is 5. For integer, we didn't cover this one, but for integer multiplication, you know what the empty value is? 1, exactly. Because 5 times 1 is 5, and 1 times 5 is 5. That's basically what a monoid is. There's actually a monoid law that says like the operation has to be associative, which we don't have to get into, meaning it doesn't matter if I have I say the operation is associative, meaning if you have 5 integers, 5, 10, 11, 6 or 4, 2, you can, it doesn't matter if you, I can take 4 plus 2 and then sum it with 10 plus 11, and then sum that with 5, or I can take 5 plus 10 and sum that with 11 plus 4, and so on and so forth. But that's it. So let's see how do we encode this in like a monoid? So let's actually take this example of our summing or array concatenation. Or summing integers. Let's do that one, and let's rewrite this as a monoid. Okay, so let's we have integer addition. How do you spell addition? So the operation for integer addition, if we have 2 integers, a and b, is going to be return a plus b. And our empty value is going to be 0. And what that means is then we can rewrite this. Instead of saying, this is total, we can basically import this function fold m from monoid. It means that we can apply. Hold on. I've got I can apply a fold m integer addition cat. And hopefully that is going to, that's going to run the total. Now, let's have a look at this this foldm function. Ignore that for now. So essentially what we do is we take a monoid and a list of values, and then we just run the operation against the aggregate, and then we start with monoid.empty. I'm surprised that actually worked from before. But the point is what we're doing is we're abstracting that reduction into a single function. So if we can define a monoid over an operation in a data type, then we can use this one foldm function anywhere. We don't have to write it ever again. And so, yeah, let's look at that again. Did that work? No. We can do the same thing for our array. Hold on, someone's trying to get hold of me really urgently. Hello, this is Charles. Sweet 208. Okay. Okay. All right. Bye. Oh, that was lunch. Okay. Part of the lunch and learn. That's our lunch on the way saying, where exactly are you? So let's have a look at our string concatenation, and let's try and do that with a monoid. So we can say let string concat equals operation for string concatenation. We have two values. Just return the concatenated value, and then the empty value is the empty string. So oops. Okay, use that same foldm function, which stands for fold monoid concatenation. And oh yeah, we forgot to import. Run that again. That's a favor again for lunch. Hello, this is Charles. It's on the second floor, suite 208. 308? No. Yeah, 208. All right, thank you. Okay, bye. Okay. Okay, and so you can see it concatenated it, but we didn't have to actually define the function to do it. We just passed in data, right? We passed in the monoid, and we passed in the list of values, and this took care of it. And the same applies for, so we did the summing integers. We could do the same thing for array concatenation. But there's actually some really, really interesting stuff that you can do with this. And this came down to something that we were doing yesterday. where we were trying to do transformations on strings. And so let me go ahead and we'll do it here. What we were trying to do was we had a bunch of strings that were going to we were trying to do transformations like between dash case, like kebab case, and snake case, and camel case. And we were working with the inflected library, which only can convert to all the other cases from underscore case. And so what you can do is you can actually, it's a surprising result, but actually function composition is itself a monoid. So basically, like, let's say we want to take, let's do, like, let's say we want to do something where we have a function that's like join. And we want to return strings.join with space like that. And then let's say we have a function that's like white space to underscore. And you know, we could then have, and then we have camelize from inflected. Really only does underscore. And let's say what we really want to, when we want to underscore something or camelize something, we want to say let camelized camel case equals, we're going to first take white space or join strings. Then we want to take that and run it through white space to underscore. Like that. Then we want to say from underscore to camel. Sorry. Like this. Okay, and we want to, so we want to, that should, camel case is undefined. Okay, oh, whoops. What is it replace? Oops. Anybody help me out? Is it like that?
Yep.
Okay. Just oops. Oh. So now you can see we took these things, we joined them all together, and then we were able to make them into a camel case thing, which maybe we can use that for a command class name or something like that. Now, it turns out that function composition is actually a monoid. So what you can do is say the operation takes one function Another function takes two functions, just like addition takes an integer, or string concatenation takes two strings. Function composition takes two functions, and it returns a new function. And all it does is it returns the result of applying like that. Now that's a little bit abstract, but that's what we're doing here when we're doing function composition, except we've got three functions. So what we can do is we can use, because function composition is a monoid, we can use that to, by the way, does anyone know what the empty value? The empty function is the ID function. So given any x, it just returns x. See that that's true. Like, if I have, let's say I've got, so let's see, I can compose this with any function, and it'll be the same function. So if I say, does that make sense? So all it does is it just returns the value that it got. So if I take a function and if I put the ID function here, it's going to give me the same function. If I put the ID function here, it's going to give me the same function. So, but what's cool then is now I can use, instead of defining camel case as this thing where I have to keep track, I can actually say, let camel case and then the value, the functions that I want to use are like that. And so I'm just folding over function composition these three functions, and that gives me the composition. Should. Anyway, let's see if it works. Oops. Oh yeah. It gave me the functions. So it actually, the result of the fold was a new function. But what I was able to do, if the screen will update itself, is you can see I was able to compose those functions, but the fold is the same. And so you might, so what's interesting is we've just extracted this concept of reducing a bunch of values into, mashing them together with this empty value. And that's really powerful, because you can conceivably say, well, let's write this function. But let's say we wanted to have a fold in parallel, where we had a whole bunch of functions that we wanted to compose, or a whole bunch of integers that we wanted to sum, or a whole bunch of strings that we wanted to concatenate, and we wanted to take those off and put them on a web workers, a bunch of web workers. Well, we don't have to intermingle that logic with the core concept of we're just mashing these things together. And so you're able to abstract these operations that you're doing, like that, how they actually are going to happen. So like suppose we wanted to do this in a web worker, we wouldn't need to specify anything else other than the operation that we're doing. Now I didn't implement this because I started doing this at 10 o'clock. But we can leave that exercise for the reader is, you know, given this thing, I should be able to do this string concatenation inside of a web worker, where each thing happens. And so, you know, if I've got a list of 10,000 strings, that might actually make a lot of sense. But I shouldn't have to change any of the code other than specifying what operation I'm doing on this monoid. And so that's it. That's it. Just, it's that simple. It's about matching things. There are things that can be matched together. And it's not meant to be an exhaustive tour of like monoids or category theory, but what I hope that this demonstrates is that this is something that we do all the time, and there is a name for it, and they're actually well understood. And so I think that these concepts are like a framework that just have terrible documentation and no guides. But monoid is a weird name, but it's not a weird concept at all. And that's what it is. It's actually not that complex. Does anybody have any questions?
Did you see Stephanie's question?
What was Stephanie's question?
Do you always need to define what empty is?
Yes, you always need to define what empty is. That's part of what a monoid is. It's got, every monoid has this empty value. Because otherwise, you know, you don't know, yeah, otherwise you don't know how to do your reduction. Because you can always start with, if you know that you have a value, because this operation takes two of the things and mashes them together, but you have to start with one thing. So if you have the empty thing, that when you mash it with the first thing, it always returns like the list with the first, or the result of the operation with the first thing, then you can always start on your list. So it's kind of how you generate that first value. And you can see when you're doing it by hand, when you're reducing an array by hand, you have to always start with the empty array. Oh, here's another one. Here's another great monoid that you might have found yourself working with a lot. So I was starting in on this as example, but essentially, let's merge three objects together. So like a lot of times you'll have like the defaults, the current value, and like the next value. And let's say the current value is name is Bob and is valid true.
Example looks familiar.
Yeah. And then maybe you have name, next value is, or like next value is just, email is bob@gmail.com. And we want to say, essentially, we want to do object assignment. And I've got, so we want to say assign defaults, current value, and then assign that with the next value. Or just assign this, and then we always need to like that. But you can also model this. It turns out that object merging and assignment is also a monoid. They're everywhere. They're freaking everywhere, man. And so what we can say is like object assignment. What's that? So what's this going to be? What's the operation? be, actually in this case, we can just say operation is a sign, and the empty value that. And so we can say our merged value is going to be, we're just going to do our fold monoid with object assignment. And we're going to say defaults. Oops. There you go. In this case, it's not very verbose, but again, once we've got the monoid defined, if we wanted to do it, say, in parallel, we could do that. Right? We could take any chunk of objects, like if we had 10 objects that we wanted to merge, we could merge 3 of them on one worker, merge 2 of them on another worker, and so on and so forth. And so there's probably a lot of other things that you can do with the monoid that, you know, I'm not going into here, but those are just two examples there. Are there any other questions?
Stephanie asked, is maybe a monoid?
I have no idea if maybe is a monoid. Let's think about it. So there's 2 things. One is a monoid implies an operation. So it's not just a data type. So for example, we have in integers, so we have summation. There's 2 monoids here. We have integer addition, which is addition over integers, and we have multiplication. And notice they're different. In one, the operation is addition, and the empty value is 0. In multiplication, the type is still integer or number, and the operation is multiplication, and the empty value is 1. So, but it's the same data type of number or integer. And so maybe so the thing that you have to ask is what operation on maybe? Is it a monoid? And so it's an excellent question. And I don't know. I don't know. Any other questions? Nope. All righty. Let's see. Well, in that case, I will, in that case, I guess that's it. Thank you, everybody. Exactly. Like I said, I think that that people would be shocked to find how common common these patterns are, like how we use them.
You're still live.
From day to day. All right. Yep, I'm still live. So bye bye.